morning, good afternoon, and good evening from wherever you're listening in the world to this podcast today. My name's Paul Webb. I am the founder of B2B Energy, and you are listening to Energy Speaks Back. Good morning, good afternoon, and good evening, and welcome to episode 8 of Energy Speaks Back. Weekly, I present to you experts around the world. Our subject today is innovation, and in particular, hot water heating. Our objectives is for energy experts to gain good understanding of innovation and heating systems around the world. So today, I'm joined by an expert in his field. This person is new to our industry and has served significant time in plumbing services. He has a good understanding of how systems can be enhanced to save energy. He's based in Essex and he has become a very close friend of mine after doing some work for me on my own property. So without any further ado, I give you Keith Myler Dixon. Good evening, Keith, and how are you?
Very well, thank you. Yourself?
Yeah, not too bad. It's really good to see you. It's been a long time, except for I am inundated with your WhatsApp messages on a regular basis, which I'm sure we'll pick that up shortly.
Yeah.
So, Keith, our friendship has gone a long way. You've done some work for me, and I think I checked this out the other day. It's 4 years ago since you first come to my house and done that work. And Since then, our friendship has really grown. So definitely. I know a lot about you, but the listeners tonight don't know much about you. So tell us about yourself.
Well, my name's Keith. I'm a domestic heating engineer. I started off my career doing tennis courts, building tennis courts all over the country. That lasted about a year. Then I moved on to scaffolding, where I had a 2-year apprenticeship doing that. That went pretty well. Ended up running my own scaffold company, but I lost interest in that. And then looked over into the heating field where my brother works and thought that was pretty much a little bit more me. So I trained up doing that and got into that. And to be honest, I haven't looked back really. So that's what's led me up to where I am now.
I think you've understated a lot of that, Keith, because your craftsmanship regarding controls. You took one look at my gas boiler, the way it was wired, and you just rewired it for me and say, now that would work better. And it has worked better. Your eye for efficiency is amazing. So tell us about your background regarding that.
Well, we grew up on farms when we were kids. With my dad, very busy, very hands-on. Anything that would break, he'd pull it apart, see why it had broken, try and fix it. Cardboard boxes or cereal boxes for new gaskets and all sorts of crazy ideas, and looking outside the box of way to get things back up and running. And to be fair, I think that's sort of fed off down to me and my brothers, really. We're all the same. We're always looking at how things are done, how you could improve them. If they break, you always pull them apart to see why they break. So you never just throw it away, because if you can fix it, fix it. It's a tinkering family, really.
Well, you've definitely done some tinkering with the boiler that you've been working on and the pictures you've been sending me. I must admit, when I first started seeing those pictures, I'm thinking, where is this going? Because it looked like you was building at one time some form of time machine.
Yeah.
So tell us what you've come up with and where you started and where you've finally arrived.
Well, we've come up with a high recovery hot water cylinder, which outperforms anyone on the market at the moment. We started off with a job we was looking at where they had 2 tanks in a restaurant and they wanted to move it into a smaller vicinity. So we looked on the market to see what was available. We found one tank, which was quite an interesting design, which you could shrink down the install size, and it will give you just the same amount of hot water output as what you'd get from the 2 tanks. And while I was looking through the drawings and trying to work out how it worked, I just looked at it and thought I could make that better. And just, then I started doing the drawings, sent them over to you. Just shrugged the first biro ones off and laughed it off, I think. And then I went back to the drawing board and done some little bit more detailed ones, which obviously when you said that might have something with it, that's pushed it forward, really. Otherwise, I probably would have left it. But I've got one now made in the garden, and it's proving real promising results. Or my time machine, as you put it.
But so the figures that have been really getting my attention are the time it takes to actually heat that hot water, which is significantly quick. And not only that, it's the kilowatt hours that you're actually saving by heating that water so quickly. So can you give us some more detail behind that?
Well, it's heating 100 litres of water in 8 minutes, the one in the garden on a recharge, which basically you're thinning the water out as it goes through the tank. So you're heating water in smaller volumes. We spoke to some technical teams from Dakin and some of the air source heat pump companies, and I was explaining to them that we've got a tank, it's heating 100 litres of water and 15 kilowatt boiler, which, to be fair, it's probably not operating at 15 kilowatts. It's hemorrhaging out of the heat exchanger. So I know that's on its last legs. And they came back with a formula saying, well, to do that, you'd need a 28 kilowatt boiler to power it, to get that volume of water hot with the temperature rises that we're getting in 8 minutes. And I sort of looked, well, my one in the garden with no insulation, no top, with broken boiler, I'm achieving it. So there's definitely something.
And what is the kilowatt rating that you're delivering that with?
It's 15 kilowatt, the boiler we're operating it with. 1.5 kilowatt hours, I think, is it?
And we done the sums on this the other night, and I think we were saying it's circa 50% savings.
Yeah, it works out. R1's doing it at 15 kilowatts. So they recommend it's 28 kilowatt boilers for that, in that time frame, to get that heat into that tank. So it's about 60% more efficient than the conventional tank. So it's definitely an interesting one.
Now, when, from being an energy expert and looking at what you've achieved there, Keith, when we're going around, so ESOS, energy saving opportunity schemes, and we've been looking at, say, care homes, for instance, there's loads of domestic hot water tanks that, how do we replace, we're looking at replacing those really to improve the efficiency of those. But the efficiencies that we're looking to gain from that is nowhere near 50%. So if we was to look at replacing your system with that and achieving 50%, that energy saving opportunity scheme does become more palatable to the client.
We're very hopeful that we can plumb it straight into an air source heat pump without the need of buffer tanks, because it's 2 tanks R1, and you've got a heating store on the outside, the domestic water tank on the inside. So the outer tank would double up as a buffer tank, so you can draw your heating water directly from the outer tank. So I'm hoping that when we get the tank, we can put it into our property, put a heat pump outside, plumb it up pretty much like a normal boiler would be. Our tank operates really well at low heat temperatures, because the way we recirculate the water in it, you can claw that heat out of the flow of the heating water in the outer tank to a near enough 100% transfer rate on it. Most normal tanks, you're not getting that, and the return temperatures are coming back to the heat pump, so they end up saturating themselves. You end up with lukewarm water. So hopefully we can get away. It gives a viable option for a gas boiler replacement with heat pumps. So
we're looking at normal domestic. So we could replace the gas boiler as well as the tank. Is that what you're saying?
Yes. Yeah, get rid of the gas boiler, put this tank in. We got the outer tank, the water circulates, so it takes the longest route for the flow from the top to the bottom of the tank where the return is, so you get good flow and return differentials. It works on the hot water priority, so if you've got your hot water running, it stops doing your heating and concentrates on your hot water. Pretty much like a combi boiler, really. It's the same sort of Same sort of concept on a bigger scale. You get better flow rates in the combi boiler and half the kilowatt power to achieve more hot water.
So have you timed how long it takes from start to finish?
Yes, it was 10 minutes from completely cold internal and out to external tank. It was 10 minutes to get the whole thing up to temperature on my dying 15 kilowatt boiler. I mean, we got the temperature on that set of 55 degrees to try and simulate as close as we can to a heat pump, and that's what we're achieving. So quite excited with it.
And tell us about the manufacturing side.
Well, we've had to go abroad. We've spoke to quite a few manufacturers here in the UK, but because of the intricacy of the manufacture, it needs a lot of laser welding. So to do that process over here is extremely expensive and almost priced us out of the market. But we found a good manufacturer that sources solar tanks to EU, Europe, and America. They've taken a look at it and tweaked a few of the designs for their manufacturing purposes. And to be fair, probably made it better and gone with that. So we've got a company in China now that's looking to make it on a large scale for us.
And we've spoken about this. Are you looking for it to be retrofit or new build?
I think we can do both. Definitely in the new build because of the insulations and everything else. It's a lot easier to insulate pipe work and put the systems in. But to be fair, the way R1 works, it's all, there's no magical contraptions that got to go with it. It's just does it itself per se. So all you need to do is take the old tank out, put R1 in, and then straight away you'll start saving your energy with using our tank. If you're using a heat pump, you probably have to insulate some of the pipe work to retain as much heat as you can on the circulation basis to make it so it's not too alien to the people living in the properties. But I'm pretty hopeful it'll work really well, so we can fit them in both.
So am I getting this right regarding the installation side? Where normally if you was to be putting a gas boiler and a domestic heater off the back of this, like an immersion tank, which is what we're replacing, you're going to, the level of technical or the accreditation, the ability of that person putting that job in is going to be reduced because you don't need that because it's not gas safe, etc.
That's it. You'll need someone to put a heat pump in, but the actual tank, any plumber with a G4 hot regulations ticket could come in, take your tank out, put R1 in, minor alteration of the pipe work, switch it on, and away you go. It could work with a gas boiler, it could work with heat pumps or any other form of heat source that you'd like to put into it, really.
So dare I say the actual installation costs could be reduced?
I think so. There's at the minute with heat pumps and all of the buffer tanks, if you look at a lot of the systems, they're quite intricate. There's a lot to do for a plumber to fit them. With R1, we're hoping that you can get rid of half of that kit, just have our tank, have a heat pump, and away you go. Hopefully it's as simple as that.
Are you have you considered the maintenance of this system afterwards? Is there much maintenance to be done?
No, look, we were concerned about limescale because we're thinning the water out into small volumes, so we've used a stainless steel corrugated pipe, which helps reduce limescale build-up as much as possible. Limescale doesn't stick to curved surfaces very well. It's only flat surfaces it sticks to. But if you run the tank at a lower temperature at 55 degrees, 50 degrees, which is still hot water, it still burn your hands if you put your hands in it, then you don't really get much limescale build-up anyway. It's only once you start going above those temperatures when you start dragging limescale out. So it's bringing the temperature of the tank down. You can bring the gas consumption or energy consumption down. You've got no limescale build-up. So hopefully it should last quite a long time.
Right. And I've seen some posts you've done recently of your youngster doing some work on the system.
Yeah.
What's the story behind that?
He just grabbed my spanners and wanted to come out and help. we had the first copper prototype delivered from a company in Newark. They helped one of our first designs and sent some tanks over for us. They were too busy to make a copper version of it. And obviously, when it all arrived, I unpackaged it, and my youngest, he's very hands-on, keen like myself. And yeah, I couldn't get him, away from it. If I'm honest, I wanted to build it, and he just took over. So it was quite good. And if it does take off, if it is a big thing, it's definitely a video I'm going to keep for the later on, because I'm sure he will love to look back into his past and say, "Look, I built the first one with my dad." So I think that'll be quite a nice thing for him to remember when he grows up.
Yeah, and you know what, I was mentioning this the other day to you, but it reminds me of a story of my father. So, I grew up. My dad was an engineer in the naval fleet air arm. So he used to work on the planes before they took off on the flat tops. But so he was a cross between in the Navy and in the RAF, and big engineering background. And he worked for Fords.
Right.
And I used to bring a Ford car home. Being young, I had to buy Fords. My dad wouldn't let me buy anything else. And I used to bring it home, be very proud of this car, the color, the lines of it, etc. And he'd take one look at it, and he wouldn't actually say, "Oh, yeah, great car." He'd lift the bonnet up, get underneath inside, and look at the water pump to see what the number of that water pump was, to see whether he actually made that water pump.
Oh wow!
When I look back at that as a child and remember those stories, and it's a great memory to have. And I'm sure your son will have the same memory of when he used to have the spanners working on that time machine in the back garden, maybe.
Well, we're still here in the present day. We haven't gone forward. I mean, it would be nice to go back a few weeks and pick a lottery ticket, but it's not.
It'd be nice to jump forward to see how it
see
does
where it
unfold.
goes. It's definitely surprising. I mean, I'm getting people from Australia, America, some in Asia. They're all private messaging me, talking about it, trying to find out the spill. To be fair, I could probably, it wouldn't take long. I could sell one now probably, but we're still waiting for the first one to turn up. But
for me, again, the technology of what you've got there. So it isn't a seasonal thing. So as an energy expert, I like to look at stuff in the winter, and what really affects us in the winter and in the summer. So taking those two extremes, you then got your limitations regarding the country you're working in.
Yeah.
So in the UK, we're going to need heating, not so much cooling, though we are seeing a lot of cooling requirements in the UK at the moment because of climate change. But then as you take that across the world, that does vary. Would you want to be doing heating systems in the likes of Dubai? Well, this isn't about that. This is heating water. Everyone needs to heat water. And if we can heat water efficiently, which is the big problem, then there isn't enough solutions around to provide heating of water, in my opinion.
Yeah.
So, Keith, what I like to do now, and another thing I've sprung on you, as well as this podcast tonight. So, have you got any messages for people listening to you tonight? It's all about innovation. You've come a long way. You haven't been in the industry very long. You've actually started to think out the box regarding this technology. So, have you got anything to give back to the listeners tonight?
Chase your dreams. If you have any ideas, look, chase them. This one come from stirring a pot of baked beans, to be fair, to evenly heat them, which is why the tank spins the outer water. So it was one of those things. I could have very easily let it go, but yeah, a few nudges from a few people, and they pushed me to keep going with it. So yeah, just pay attention to what you do, how your footprint is, leaving lights on. It all adds up, and in a world where we are the smartest creatures on the planet, and when I look at us as a race, we're the ones destroying it the quickest. When we should be looking after it, really. So I mean, anything energy-wise, anything that we can reduce our carbon footprint will be most welcome. So if you have those ideas, push them.
That's brilliant. So Keith, I think you've got an amazing technology there. I've seen it from the start to where it is today, and it has massively sort of impacted the way I've started thinking about what you're doing there. And I think you've got something there, and I hope I wish you every success with what you've got there. And I'm looking forward to seeing the story unravel even further. So, thank you for joining us tonight.
Thank you.
I wish you and your family well and stay safe in these times.
Yes, and you. Thank you, Paul. Cheers. Speak soon.
Okay, take care.
Take care. Bye.
Thank you for joining me today on this podcast, and thank you for my special guest. Please go and check out our website on www.b2benergy.co.uk, where you can see many more insights to how you can manage that third largest expense. Thank you. That just leaves me for one more thing to say. Be safe.